All right, I'm here with 52 weeks of Swift, and I'm continuing going through the language guide. I'm on methods now, and this is a good topic to cover. Methods are fun because they allow you to add additional functionality to classes. So let's go ahead and dive right in. I'm going to go ahead and share my screen here and talk about this. So let's go ahead and share screen 2. Perfect. Okay, so I'm in the Swift documentation. We can see methods or functions that are associated with a particular type. Classes, structures, enumerations can all define instance methods, and these encapsulate a specific task for working with an instance of a type. And if we go ahead and get started here, we can take a look at instance method, which are functions that belong to a particular instance of a class, structure, or enumeration. They support the functionality of those instances. So a lot of times you have some kind of state inside of your instance and you want to operate on that state. So you have an instance method that will help you do that. So here's an example right here. We have a counter, and in this particular example, we have an increment, by, and a reset, right? So this would be a good example right here. So in this case, this function is the method. It's associated with the class counter, and there's a second method, which is increment, and there's a third method, which is reset. So if we run this, let's go ahead and get this. So for some reason, my playground is whacked out here. I might have to start a new one, which is, oh, I think it's okay now. And so we see here increments by 1, increment by is some kind of an increment. So first up, let's go ahead and run this class by instantiating it, by making a let counter. And in this particular example, for some reason my playground's messed up. Not a big deal. I'll just go ahead and recreate it. And I'll go here and say file, new playground, make a new one. And I'll call this my method, add this up here. Here we go. Yeah, for some reason it was failed to prepare for communication with playground for an unknown reason. Not sure what's going on here, but my playground is whacked out, which definitely causes issues, but we can definitely work around this. I'll just cover it in essentially without running the code. That's probably the best way to handle this. So I'm just going to walk through the code here and take a look at it and figure that out later. So if we go through here and we look at the instance here, there's increment by 5, and then you can reset. So this, I think, explains the concept of why you'd want to use a method, is that it's doing something to the state of the instance of the object. Now, the self property is something that comes with every instance. And so in this particular example here, if I said function increment self.count, this is basically incrementing the state of that object. And so this is identical, in fact, to the way things work in Python. And in this particular example, we're actually using the self. So it says in practice, though, you don't need to write self very often. If you don't explicitly write it, Swift assumes that you're referring to a property or method of the current instance whenever you use a known property or method name within a method. So I guess if we go through here, because inside of this increment, let's see how it's defined. You don't have to use self because in this case, this is already associated as an attribute of the class. And so it knows that you're incrementing because I'm using that same name, you're going to increment the instance of the class. So it's a kind of a neat little syntactic sugar that you can actually be aware of. So here's another one. Here is a example of how you would use self to really an exception to that, where the parameter name takes precedence and it becomes necessary to refer to the property in a more qualified way. So in this particular example, we have a struct, which is a point. We have some state here, and then we say is to the right of, return back self.x is greater than x. And so I guess in this case, because you're having two kinds of state, you're actually explicitly referring to the instance X. So you can also modify value types from within instance methods. So structures and enumerations are value types, and that means that they can't be modified from within its instance method. But if you do need to modify it, you can opt into mutating behavior for that method. So in this case, you can actually call a mutation here to mutate inside of this function. So what else can you do? You can say assign to self with a mutating method. In this particular example here, we can see that the struct point, we have in this particular method also a mutation here. And so the point example shows how it can be written here. The version of the mutating move by method creates a new structure whose X and Y values are set to a target location. So definitely an interesting concept here in Swift, that you have to actually explicitly tell things to mutate, and because it has such a strong support for immutable variables. Now, if we look at type method here, instance methods, as described above, are methods you call an instance, but you can also define methods that are called on the type itself, and these are called type methods, and you can indicate type methods by writing static before the method's function keyword. And this allows subclasses to override the superclass's implementation of that method. And so in this case, I guess, let's say we have a class here called SomeClass, and then we have a function. This would be the type implementation goes here. I see. And all of the game's levels are locked in when the players first started. And then later you would go through and track the current level for an individual player. So it's kind of a nice use case here to have a game scenario, which could be very well suited to object-oriented programming, like a level tracker. In this case, the level tracker is used with a player class below. And so in this particular example here, we have an immutable variable that's created. We have a mutable variable tracker. We have an immutable variable player name here. And then we've got this class method right here that's able to operate on some of these components of this. And then in this particular example here, we have a player class that creates a new instance of level tracker. So the idea with this object-oriented programming is, in these kinds of scenarios where there's an individual instance that's been created of, let's say, a player in a video game, there's all these things you'd want to do to the state, like keep track of the level they're on, what are their operations. And so the classes in Swift work very well. So kind of an interesting little chapter here. I'll definitely play around with this when I get some more time. But go ahead and take a look at type methods. This is, I think, a decent tutorial. I would say this is probably the most powerful part of the tutorial, this first part, because it's a very clear explanation. And then I would say the second most powerful component would be to be aware of this self method. Some of these more advanced things are interesting, but I would probably focus on these first two parts. Okay, well, that's it for me today.